Welcome back. This is Mrs. Rubright with Advanced Geometry. Today's class is 5-4, Use Medians and Altitudes. You should have began by already copying the for your notebooks on page 321 and 322. In triangle RST, Q is the centroid and SQ is 8. Find QW and SW. Okay, so in triangle RST, Q is the centroid. SQ is 8. Find QW. Alright, so going back to Pamasico. Alright, so far, let's just get rid of this part. Alright. So far, what we are supposed to know is that P stands for perpendicular bisectors. This is Pamasico. Perpendicular bisectors meet at the circumcenter, right? Perpendicular bisectors meet at the circumcenter. What's important about the circumcenter is the distance from the circumcenter, the distance of that point of concurrency, to each vertex is equal. All right, so you find it using the perpendicular bisectors, and then the distance from that point of concurrency to each vertex is equal. Angle bisectors. Your angle bisectors meet at the incenter. The point of concurrency of your angle bisectors is called the incenter. The distance from that point of concurrency to each leg or each side of the triangle is equal. So it's almost like you can have a circle inside because those are all radii. Where on perpendicular bisectors, you end up having the triangle inside of a circle. Okay? So now this is what's new, our medians. The point of concurrency of our medians is the centroid. And what's important about the centroid is it splits each of those segments, each of those medians, into a 1/3, 2/3 relationship. All right, so it's a median. A median means that it goes from the midpoint to the vertex of the opposite side, right? So these are equal down here. And then these are medians, so these are equal, right? And their point of concurrency does the 1/3, 2/3. So if this was 5, double it, 10. Make sense? So let's go back to our problem. So over here, if this is 8, if that's 8, then this is half that. It's 4. 1/3, 2/3. The whole thing is 3/3, right? 3/3 is 1 whole. Is everyone understanding this? That this is half? Okay. So they wanted to know what is QW and what is SW, the whole thing. So QW is 4 and SW is 12. And they're just overcomplicating it a little bit. They're just saying, okay, if 2/3 of x equals 8, then I multiply by 3/2 to get the whole 12, and then 12 minus 8 is 4. You can just think of this as, okay, if this is 2/3 and this is 1/3, if you split it into 3 equal parts, wouldn't that be 4, 4, and 4? Kind of a little bit more simple to just do it in your head. Make sense? All right, so the vertices of triangle FGH are as follows. Which ordered pair gives the coordinates of the centroid of FGH? So the first thing you're going to do is you're going to sketch the triangle, and then you're going to use the midpoint formula to find the midpoint of K, of HG, and you're going to sketch the median GK. So I actually want to do this separate sheet of paper just so that you guys can see this, how you would do this in real life. All right, so we have F at 2,5, G at 4,9, and H at 6,1, and then they want the centroid. All right, so going back to here. One, two, 1, 2, 3, 4, 5. Get into the elevator before you go up or down. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, 6, 1. I'm going to need a straight edge. So it's made up of medians. We need to know where our midpoints are. So if we're going down 1, 2, 3, 4 over 1, 2, 3, 4, half that would be down 2 over 2. Right? Down 2 over 2, down 2 over 2. There's my midpoint. Let's do another one. This one's over 1, 2, down 1, 2, 3, 4, 5, 6, 7, 8. So how about up 4 over 1? Up 4 over 1, right? Halfway. And after I have two of these, you can clearly see where it's supposed to be, right? And then this is going to be up 1, 2, 3, 4 over 2, so up 2 over 1. All right. So we are at 1, 2, 3, 4, comma, 1, 2, 3, 4, 5. Does this make sense? Well, right here is a height of 2 versus a height of 1, 2, 3, 4. It splits it into that 1/3, 2/3 relationship, right? Here's 1 versus 2. That 1/3, 2/3 relationship. Is this making sense, guys? I'm going to move this F just so it's not in your way of that 2. All right, are we okay? All right, so I'm back here. They sketched the graph and found their midpoints. You can use slope, or you can actually put it into the midpoint formula. Add your x's, divide by 2. Add your y's, divide by 2. And like I said, you only really need one of them to be able to figure it out, right? Because it's going to be that 1/3 versus 2/3 relationship. So if you had a total of 1, 2, 3, 4, 5, 6, 6 divided by 3 is 2. So it should be 2 versus 4. Okay? There are 3 paths through a triangular park. Each path goes from a midpoint of one edge to the opposite corner. The path meets at point P. If SC is 1,200 feet, find PS and PC. If SC is, did I say 1,200? Wow, I'm having issues today. 2,100 feet. So 2,100 divided by 3. Wouldn't that be 700? Yes? So we would have 700 versus, double that, 1,400, and they add up to 2,100. So what is PS? PS is 700, and PC, 1,400. If BT is 1,000, what is TC? What is TC? 1,000. Good. Because this is a midpoint, breaking it into 2 equal parts. So then what is BC? 2,000. If PT is 800, PT, 800. What is PA? 1,600, making TA 2,400. Good. Find the orthocenter P in an acute, a right, and an obtuse triangle. With your table partner, I want you guys to draw 3 different types of triangles and find their orthocenters. Are their orthocenters inside, or are they on it, or are they outside of it? Okay, so orthocenter is our 4th condition. And the orthocenter, right, in Pamasico, our orthocenter is where the altitudes meet. It's the point of concurrency of the altitudes, which are your heights. So I'm going to pause the video and give you guys a couple minutes to try this out, and then we will go over it together. Alright, so you guys should have tried these on your own. So for an acute triangle, where's our orthocenter? So once again, our orthocenters are height, so we're going to go from the vertex opposite and drop a perpendicular line. So on this, these lines are perpendicular, right? So I'm just going to go and drop those heights. Okay, so I have my heights, and my orthocenter is inside of an acute triangle. Okay, let's look at the right triangle. Let's drop our heights. Well, one height is already there. This height's already there, so I just need the third height. And here's our third height, right? So if I want to color code this so you can see what I'm talking about. So this height right here goes to this base. This height is perpendicular to this base. And this height is perpendicular to this base, okay? So over here, this height is perpendicular to this base, and this height is perpendicular to this base, so they're kind of both the same, right? And then this height is perpendicular to here. So this point of concurrency is on the triangle. All right, now let's look at our obtuse triangle. Let's drop our heights here. There's one. For here, we're going to have to extend out. Okay, so here's a height. So I'm going to take this height that I already did, and I'm going to extend it. And then let's do our third height. So we already did this height right here. Goes with this base. This height goes with this base. So now we need the one that goes with this base. Alright, so it's going from here, and it needs to be perpendicular. So we're going to once again have to extend out. And it needs to be perpendicular. So this height is that one. So our orthocenter is outside the triangle. And if you want to see where the original triangle was, just for those of you who are having a little bit of trouble seeing it, put a shade in the original. So your original triangle was this in here. Alright, just so you guys can see where the original triangle was, here's my original triangle. This is my orthocenter, located outside of the original triangle. Okay, so if it's obtuse, it's located on the outside. If it is right, it is located on the triangle. And if it is acute, it is located inside the triangle. Okay, so that is your orthocenter. It's your point of concurrencies of the altitudes, which are your heights of the triangle. Alright, so going back to our flip chart, prove that the median to the base of an isosceles triangle is an altitude. Alright, Well, actually, before we do this, let's just go back right here real quick and just add to your Pamasico. So your Pamasico, you need to know all of this by heart. And this nice mnemonic helps. Your perpendicular bisectors have a point of concurrency called the circumcenter. The distance from the circumcenter to each vertex is equal. Your angle bisectors meet at the incenter. That point of concurrency to each leg or each side of the triangle is equal. Your medians meet at the centroid, breaking it up into a 1/3, 2/3 relationship. And your altitude's point of concurrency is called the orthocenter. And it is located on the triangle. If it's a right triangle, it is located in an acute triangle, and it is located outside of an obtuse triangle. And this is the important things that you need to know about these different points of concurrency. So I'm going to give you guys a second to copy that down. Actually expand this. Hide this. Oh, it's kind of hanging out apart, but oh well. Yes. The altitude is at the orthocenter. On a right triangle, it's on it. An acute triangle, it's in it. And obtuse, it is outside of it. The location of the point. I'm going to pause this video so you guys can continue copying, and then we'll resume in a minute. Alright guys, so we should have finished copying the Pamasico, so now we're back to our flip chart. We're proving that proving a property of isosceles triangles. Prove that the median to the base of an isosceles triangle is an altitude. Okay, so what did they give us so far? They gave us, we have our statements and our reasons. So our statements column, number 1 of our statements, is going to be that triangle ABC is isosceles. Triangle ABC is isosceles with base AC, okay? BD is the median to base AC. Okay, so that's the given. So 1 is given. You know, your statements and your reasons, right? I'm doing a 2-column proof a little bit right there, whatever. All right, so that's R1. R1's given. So if it's a median to the base, what does that mean? A median cuts it into 2 equal parts, right? So that's already marked. This is already marked. So you could go, because it doesn't exactly like specify it, so you could say that for statement 2, you can say AB is congruent to CB, definition of isosceles. You can say that AD is congruent to CD, definition of median, right? So those are our first 3 lines. What else do we know? We know reflexive. So we know that BD is congruent to BD, reflexive. So now we know that triangle ABD is congruent to triangle CBD. Why? Side, side, side. So now that the 2 triangles are congruent, then corresponding parts of congruent triangles are congruent. So angle BDA is congruent to angle BDC. Corresponding parts of congruent triangles are congruent. Well, if they're congruent and they're a linear pair, right, then you can say that angle BDA is and angle BDC are right angles. Why? Linear pairs are supplementary, right? If they're congruent and supplementary, congruent supplements, right? So then, if these are now 90, then you can say BD is perpendicular to AC, definition of perpendicular. Therefore, BD is an altitude of, or I guess instead of saying perpendicular to, you could just say that it's an altitude, right, of it. And why? Definition of altitude. An altitude is a height. Height's perpendicular, right? So there's a few different ways you could approach this, but it's not that complicated of a proof. So you basically have everything they gave you, then state that those are equal. Why? Because definition of isosceles, those are equal definition of median. add in your reflexive. They're congruent by side, side, side. Therefore, these angles are congruent. Corresponding parts of congruent triangles are congruent. If they're congruent and they're a linear pair, then they're 90 degrees. If they're 90 degrees, then this is an altitude. Because an altitude is perpendicular to the base, right? All right, so copy the triangle in example 4 and find its orthocenter. So your orthocenter deals with your heights. All right, so once again, I'm going to do this on a separate sheet of paper because when they updated my computer, they didn't give me the paid version of Active Inspire, so I don't have a compass on here. I mean, I guess technically I do have a straight edge, but it's still just easier to do on our own sheet of paper. So I'm going to copy this down. You guys should be copying it down as well. B, C, A, C. So I made sure to make it isosceles, and I'll show you how I did that. All right, so I made a point B, and then I just went diagonally across 5 squares, so that I knew that I was making it isosceles. And then I just put this straight down, and these should both be equal. They're 1, 2, 3, 4, 5 squares each, so I know that those are equal as well. And this is asking us to find the orthocenter, which is where the altitudes meet. So let's do the next one. All right, so from here to here. And then on this side, about there. So our orthocenter, the point of concurrency of our altitudes, is inside of the triangle since it is an acute triangle. And that is how you find the orthocenter. You just drop those perpendicular heights. Okay, so once again, this height goes to this base. This height goes to this base. And this height was dropped to this base. All right, is everyone able to see that? And the point of concurrency is right there. So going back to our flip chart. We're going to take a look at this. Okay, so I clearly drew mine acute. They drew theirs obtuse, right? Because theirs is located outside, so it really just depends when you duplicate it, if you drew it exactly how they drew it. So if I draw one intentionally obtuse, let's do that. Right back here. Let's draw it more obtuse. Alright, so how about I go from here to 4.5. From here to 4.5. And connect them. Okay. So now, is this acute? Is this acute again? Am I bad at drawing, let's say? I made it 90. Let's try again. Let's draw an obtuse one. So apparently I'm not good at drawing obtuse. Alright, so let's check this angle. It is definitely obtuse. Okay, so we're good. I can finally draw an obtuse triangle, an obtuse isosceles triangle. So let's zoom out on this a little. Okay, my first attempt was acute. My second attempt ended up being right. The third attempt, I finally have an obtuse. Let's drop these altitudes, these heights. So Here's one. We have to extend this guy out. Dropping from here. Oops. Wow, this thing's going to be huge. It's going to be located way out here. Let's do our third one. So we already have the height that goes with this leg. This is the height to this leg. So now we need the height to that leg. So we're going to have to extend this dude out. We're going from over here. I'm slightly off. Oops, I can't even draw. Anyway, so this one and you can see that our orthocenter is clearly outside our original triangle is here. Okay, that's our original triangle, and our orthocenter is located outside. All right, I hope you guys are starting to get this. Let's go back to here. And suppose you wanted to show the median BD is also an angle bisector. How would your proof be different? So if you wanted to show that it's an angle bisector, you would do the same thing with stating your givens, right? This is the congruent to this is congruent to this. You're going to add in your reflexive, BD is congruent to BD, so the two triangles are congruent by side, side, side. Then you would say angle ABD is congruent to angle CBD. Corresponding parts of congruent triangles are congruent. And then because these two are congruent, then it's an angle bisector, definition of angle bisector. Done. Right? Ooh, sorry. So triangle ABD is congruent to triangle CBD by side, side, side. And then you have the angles are congruent, so making BD an angle bisector, all right? Triangle PQR is an isosceles triangle, and segment OQ is an altitude. What else do you know about OQ, and what are the coordinates of P? It says that this is an altitude, and it says it's isosceles. Well, if it's isosceles, then the base two angles are equal, base angles theorem, right? Okay, isosceles, this is an altitude, this is a height. What else do you know about OQ? All right, well, what do we have? We have reflexive, right? So by angle, side, side, no, but this is 90 degrees, so it's hypotenuse leg. So by hypotenuse leg, these two triangles are congruent, therefore corresponding parts of congruent triangles are congruent. So this is also 90. These are equal. So not only is it a altitude, but it is a perpendicular bisector. It is a median, right? It goes from the vertex to the midpoint of the opposite side. So it's a median, it's an altitude, it's a perpendicular bisector. What are the coordinates of P? Well, if this is H0, then this would be what? Negative H0. And that is everything on your lesson on 5.4, use medians and altitudes. I hope you guys enjoyed this lesson. Please like and subscribe and have a fantastic day.